And welcome to the final lesson of Activity 23. We are on none other than Lesson 23-4, and it simply says solving triangles. If you think about it, for the last few activities, we've really been focusing on new and truthfully exciting ways to solve triangles. We started with solving right triangles, using the Pythagorean theorem, using special right triangles, using sine, cosine, and tangent. And then we were introduced to the law of sines and the law of cosines that can actually help us solve any triangle, not just right triangles. So the title tells us we are going to solve triangles. And remember, what it means to solve a triangle is find any unknown measure. And if a triangle has 3 sides and 3 angles, we need to have all 3 side lengths, all 3 angle measures, and that means we have solved the triangle. So let's look at our learning targets. Today we are going to determine when to use the law of sines and when to use the law of cosines. So 2 new ways to solve triangles, and we need to figure out when to use the law of sines and when to use the law of cosines. And once we figure out the best method or the best route to use either law, we're going to start solving problems using the law of cosines or the law of sines. We can actually use these 2 different laws together, depending on the information that's given. So let's take a look. For starters, we're going to chunk item 1. Item 1 is how we are going to distinguish when to use the law of cosines or use the law of sines. Notice that they have on the left here, most notably what we referred to when we were talking about triangle congruence or triangle similarity. Remember, the A stands for angle and the S stands for side. So take a moment, read through the text before playing through. So when determining which law to use, either law of sines or law of cosines, you always have to ask yourself, well, what do we have? What do we know? So before we even dive into this table, look at, for starters, this is the law of sines. The law of sines is simply a proportion. Now, again, we don't have to have all 3 of these ratios in order to use the law of sines, but just for example, if we knew the measure of angle A, its opposite side, and either angle B or its opposite side, we could use the law of sines. So when solving a proportion, you need at least 3 out of the 4 parts of your proportion. Now, for the law of cosines, this is just one example, set equal to A, or more appropriately, A squared. To find the length of A, you need the length of the other 2 sides as well as the measure of angle A. Or if you are trying to find the measure of angle A, you need the length of all 3 sides to use the law of cosines. So when determining whether to use law of sines or cosines, you have to figure out what you actually have. So here I have a sample triangle, ABC, with opposite side lengths labeled lowercase a, lowercase b, and lowercase c. So for the first description, which is classified as angle, angle, side, 2 angle measures and the length of a non-included side are known. So if we have 2 angle measures and the length of a non-included side, what that could look like is we can know the measure of angle A and the measure of angle B. So we can know the measure of these 2 angles, and we could also know the length of those 2 opposite sides. Either we could say A or B. And if we had these 3 pieces of information, measure of angle A, measure of angle B, and either A or B, we could use the law of sines, known as, and we're calling that angle, angle, side, for instance. Now, of course, there's other combinations. You know, we could have the measure of angle B and the measure of angle C, and either have the length of B or the length of C. If we have 3 of these measures, we can use the law of sines. And likewise, there's one more combination. If we have the measure of angle A and the measure of angle C, then we could also know the length of A or C, and again, use the law of sines. So if we have two angles and a non-included side, in other words, think about what B really represents in this idea of non-included side. It's the length of the side opposite of an angle that I already know. So if we know the measure of angle A and angle B, we just need to know the length of one of those opposite sides of those angles, and we can use the law of sines. Now let's take a look at angle side angle, where we know two angle measures and the length of the included side. So on this idea, it's a little bit unique here, because if we think about it, it says two angle measures in the length of the non-included side, or excuse me, in the included side. So what that would be, for example, we can know the measure of angle A and also the measure of angle B, but we could also know the included side between angle A and angle B, which would be lowercase c. Now you might be asking yourself, how can we use the length of C if we don't know the measure of angle C? Well, if we know the measure of angle A and B, we know that all three angles of any triangle add equal 180. So if we are just told the measure of two angles, we can find the third because of the triangle sum theorem, and therefore we will conversely have the measure of angle C. So then, of course, we could use its opposite side of C and use a proportion, for example, using the sine of C. So again, if we know two angles and the included side, what we're really suggesting here is we're going to go ahead and find the measure of that third angle, because all three angles add equal 180. And once we have three angles and one side, we can find any other side length using the law of sines. So, of course, this is not the only combination. We could do measure of angle A and measure of angle C with B. So just keep that in mind. Now let's take a look at side-side angle. So for the case side-side angle, we will know the lengths of two sides and the angle opposite of one of those sides. So for example, again, given this triangle, if we knew the length of A and also the length of B and one of the angles opposite of it. So one combo, if we knew the measure of A, we knew the measure of B, and we knew either the measure of the angle opposite of either of those sides, we could use the law of sines. So think about, this is kind of the exact opposite idea of what we said with angle side. Makes sense, right? Angle side is two angles and a side. Side angle is two sides and an angle. So we can know the length of two sides and one of the two angles opposite of the two sides we're given. So of course there's other combinations. So we can know the length of B and C, and either the measure of angle B or the measure of angle C. Got ahead of myself, or the measure of angle C. We can also know the length of A and C, and either the measure of angle A or the measure of angle C. So we can use any of these combinations using the law of sines to find other missing measures. Now let's take a look at side angle side. Two side lengths and the included angle measure is known. This is where we change into using the law of cosines. Two side lengths and the included angle measure is known. That's a little different than the previous one we just read. The lengths of two sides and the angle opposite, or the non-included angle, is another way to look at that. But this one is two side lengths and the included angle is known. And let's see why that is law of cosines. So in our example, if we knew the length of two sides, for example, A and B, and the non-included angle, or excuse me, and the included angle. So the included angle between sides A and B would actually be the measure of angle C. Well, if you think about it, I don't have a full proportion if I have the length of these two sides, A and B, and neither of their opposite angles. So I can know the length of B and the length of A, And if I don't know the measure of either of those opposite angles of those two sides, then I can't use the law of sines. I have to use the law of cosines. So one combination could be if we knew the length of A and B and the measure of angle C, we're going to use the law of cosines. So likewise, there's other combinations as well. If we knew the length of A and the length of C, but we knew the measure of angle B, we could use the law of cosines. And of course, the last combination, if we knew the length of B and the length of C, but knew the measure of angle A. So again, if we knew the length of B and C, but also the measure of angle A, that's actually this law that I wrote here as an example. So we could find the length of A, this from the distance from B to C, which we labeled lowercase a, if we knew the length of B, the length of C, and also the measure of angle A. So that's why we're using the law of cosines for two side lengths and the included angle measure. Now the last one, three side lengths are known, side, side, side. Of course we have to use the law of cosines, because in order to use the law of sines, we have to have some angle measure. Sorry about that. So again, to use the law of sines, you have to have at least one angle measure. So if we are given all three side lengths, we should know that we're going to use the law of cosines. So there's really only one combination for this. If we knew all three side lengths, we're going to use the law of cosines. So let me just do some labeling here to make sure we understand. These combinations represent angle, angle, side, which is the first case that we saw. These combinations represent angle, side, angle, which is the second case we saw. This third combination represents side, side angle. And again, we did learn that side, side angle does not prove triangles congruent because it's a cuss word backwards, but that's not what we're doing here. We're not showing that triangles are congruent or even triangles similar necessarily. We're talking about a combination of information given in order to find or solve the triangle. And this combination or list of combinations represents side, angle, side. And this last combo that we got to is side, side, side. So we're going to use this information to help us determine a route to take to solve a triangle. So now that we have an idea of which combinations we can use to determine whether or not we're going to use law of sines or law of cosines, let's start solving a triangle. So let's take a look at item 2. So we're actually going to break item 2 in half. So we're going to chunk items 2A through C for starters. What I love about 2A through C is before we even start solving anything, we're going to figure out what we know and a plan to solve this triangle based on what we're given. Then the remainder of item 2, we actually start solving this triangle. So take a moment, pause the video, complete this on your own before playing through. So on item 2A, we're asked first, what information do we know? So we are given the measure of angle C, which is 98 degrees, and we're also given the length of CB, which again I label it lowercase a because it's opposite of angle A. So we're actually given the measure of A, which is 12 kilometers, and the length of B, which is 15 kilometers. So if we notice, we are given the length of two sides and what's considered the included angle, two sides in the included angle. So this would be an example of the side angle side case. So therefore, we're going to definitely use the law of cosines as we begin. So using the law of cosines, since we are given the measure of angle C, we're going to find the length of the third side, or the side opposite of angle C, which is AB, which we call lowercase c. So the first step, use the law of cosines to find the length of AB, which again we labeled C. And then on item C, they asked us to draw a flow chart to plan a solution pathway for the problem. So this is not exactly like the flow chart proofs we saw, but just kind of similar to that idea. We see a plan written in this flow chart concept. So we're going to use the given information to find the length of AB. We said that on item B. We're going to find the length of AB using the law of cosines. And then truthfully here, sorry about that. And truthfully at this point, you could have decided to either find the measure of angle A or the measure of angle B using the law of sines, because we have the length of lowercase b and we have the length of lowercase a. So I just simply said, after we find the length of AB using the law of cosines, we're going to find the measure of angle A using the law of sines. And then, because we actually will have all three sides and two of the angle measures, we're simply going to find the third angle measure, or the measure of angle B in this case, using the triangle sum theorem, which is really just a fancy way to say that all three angles add equal 180. So once we know two of the angles, we'll be able to find the third by subtracting from 180. Of course, we could use the law of cosines again, but this route is just a little bit quicker and easier on us. So now let's turn the page and let's actually go about solving. So item D says, does your plan include using the law of sines, the law of cosines, or both? Of course, it's both. And the reason they ask this question is for us to understand that based on what's given, sometimes we'll use the law of sines, sometimes we'll use the law of cosines, or both. Now on item E, let's start solving the triangle. And I want to highlight some important points in item E. We're going to round all side measures to the nearest tenth and all angle measures to the nearest degree. So make sure you do that. So we're going to round all side measures to the nearest tenth and all angle measures to the nearest degree. So at this point, let's pause the video and see what we can do in solving the triangle. So hopefully you've taken some time to solve the triangle as they say on item E. And don't forget, we were supposed to round all side measures to the nearest tenth and all angle measures to the nearest degree. And in saying that, I realized when I wrote my answer here, I left off 0.5. So we should have gotten the length of C is 20.5 kilometers. That was the first side length we found, and the only side length we had to find. And then we found the measure of angle A was 35 degrees, and the measure of angle B was 47 degrees. So let's take a look. I rewrote the information that was given. We knew the measure of angle C was 98 degrees. We knew the length of A and B, A being 12 kilometers and B being 15 kilometers. So if I'm trying to find the length of C, I'm going to go back to the law of cosines lesson, and I'm going to use the law of cosines that's set equal to C, because we know the length of A and B, and we also know the measure of angle C. Remember, the capital letters in these laws actually represent the angle measures. So we knew the measure of angle C, and we knew the length of A and B. So C squared equals, we replace A, of course, with 12, B with 15, and we did that here and here. Notice I put parentheses up because 2 times A times B is multiplication times the cosine of replace capital C with 98. Technically, in a graphing calculator, you can key in this entire equation just as you see it here on this step. But just to make sure we do the math correctly, I went ahead and squared these two terms and also multiplied. 144, 225, and 2 times 12 times 15 is 360. Now at this point, because if I multiply 360 times the cosine of 98, which is that multiplication that we should do first, I'm going to get a decimal. So I went ahead and put this in the calculator. And the graphing calculator, being as smart as it is, it's going to multiply these two terms first, which is what we needed to do, then subtract that product from 369. So I'm going to show you how I put that in the calculator. Simply 369 minus 360 times the cosine of 98. And if you're using Desmos, make sure you are in degree mode. So I got 419.1023163646. Now, since we are rounding to the 10th, some of you might have went ahead and rounded 419.1. I think it's a little dangerous within the problem to go ahead and round. Always save most of the rounding to the end. So notice when I took, since it was C squared equals 419.1, so forth, we still had to take the square root of both sides to find the length of C. So when I put that in the calculator, I went ahead and gave myself some room there. Instead of just 419.1, I did 0.1023, went all the way to the 10,000ths place, just to make sure that my answer was close as possible. So the square root of 419.1 is 20.47, and we were told to round our side lengths to the nearest tenth. So the 7 tells the 4 to round up. So I found the length of our third side, 20.5 kilometers. So then I rehashed all the information I knew and all the information I was going to use from here on out. So when deciding at this point that we were going to use the law of sines, it's because we had the length of a side and its opposite angle. So we had the measure of angle C. We just found the length of its opposite side. And so we can use the law of sines to find an angle or a side. And we already have all three sides, so now let's find the measure of angle A. So if I'm looking for the measure of angle A, I'm going to use the law of sines that includes A. So I did the sine of A over A equal to, well, I chose the sine of C over C because we have the measure of angle C and its opposite side. So left sine of A because we don't know the measure of angle A yet, but I replaced lowercase a with 12, its measure, capital C with 98 degrees, its measure, and what we just found, lowercase c, its measure. Cross multiplied, 12 times sine of 98. And of course, you could round that here if you want to go and do that multiplication, change that to a decimal. We just have the calculators that can hold that information in there. So I went ahead and left 12 times the sine of 98. Well, 20.5 times the sine of A, we can't actually multiply these because we don't know what A is. But the whole point is to find the measure of angle A. So the first thing we need to do is get sine of A by itself. So if this is 20.5 times the sine of A, I'm going to divide both sides by 20.5. That will cancel 20.5 on the right, although what's really happening is 20.5 divides by itself and it becomes 1, and 1 times anything is itself. So I always hate to use the term cancel, even though at this point most of us know what we mean here. So we're left with, on the right side, the sine of A equal to 12 times the sine of 98 degrees over 20.5. Now at this point, recall from our law of sines and even our sine, cosine, tangent lessons, if we're trying to find the measure of angle A, or the measure of any angle for that matter, we use the inverse. So since this is the law of sines, we're going to use the sine inverse of this ratio. This, as crazy as it is, it's a ratio because it's a fraction. So the sine inverse of that ratio will produce the angle measure. So of course, at this point, I hopped over to Desmos and put that in the calculator. The sine inverse of 12 times the sine of 98 over 20.5, and I got 35.427. And they told us to round the angle measures to the nearest degree. So the 4 tells the 5 to stay where it is. So the measure of angle A is 35 degrees. Now the last thing we had to do, the simplest step, was if we know 2 angle measures, and now we do, we can find the third because all 3 add equal 180. So to find the measure of angle B, I took 180, subtracted 98 from angle C, 35 from angle A, and I found the measure of angle B is 47 degrees. So we use the law of sines, or excuse me, the law of cosines, the law of sines, and even, if you want to get technical with it, we use the triangle sum theorem. So that is the end of lesson 23-4 that we're going to do together. I will say that the item 3 and 4 on the Check Your Understanding are great ways just to, again, start processing the plan you're going to take based on what's given to solve these triangles. So I encourage you to complete 3 and 4, although we're not going to do those together. Create a plan and stick with that plan. So that is the end of lesson 23-4, a great summary, a great final lesson from activity 23. So hopefully we know now quite a few different ways to solve triangles, and we're ready to produce that on a test. So that is the end of lesson 23-4. As always, I encourage you to complete the practice lesson 23-4 below and go back to those learning targets and reevaluate your understanding. Hopefully we feel a lot more comfortable when determining whether or not to use law of sines or law of cosines. Hope that helped. Thank you for watching.